Good day to you. This is teacher Leland, Alejandro, and we're going to discuss proving lines parallel. And we're going to see the problem set in the other screen. All right, let's check the problem set. Okay, let's count the number of items first. Okay, we have here about how many? This will be about 24. Okay, 24. All right. So let us have the first problem per screen. Okay, and let's have a little concept about it. Okay, we have here the two lines with a transversal. Okay, two lines with a transversal. Now there are concepts in this diagram. We shall have the angles first. This is first angle. This is angle 2. This is angle 3. This is angle 4. Okay, angles 1, 2, 3, and 4. These are called exterior angles. Exterior. So these are exterior angles. So these angles are numbered 1, 2, 3, and 4. Okay, the other angles remaining will be called interior angles. Okay, and these are the following angle. We shall call it angle 5 here, angle 6, angle 7, and angle 8. Those are interior angles. So these are interior angles because they are bounded by the two lines. So you call this interior angles there. Okay, so just remember the positions of the angles. Angles 1, 2, 3, and 4 are exterior angles. Angles 5, 6, 7, 8 are interior angles. All right, we're going to study the configurations or angle pairs first. For an introduction, let's clear. Let's have the two lines again. Okay, the two lines with a transversal. Okay, this particular angle pair, one exterior and one interior, okay, on the same side of the transversal, this is called a corresponding angle pair. Okay, the name of this is corresponding angle pair. There. All right, corresponding angle pair. All right, let's have the next. Okay, start a new drawing. Two lines. Okay, this is transversal. Okay, by the way, a transversal is another line which intersects lines at different points. Okay, different points. So the previous is corresponding angles. The next one will be alternate interior. Okay, all right, one angle here and the other one over there. So this is another angle pair. These are non-adjacent angle pair, both interior on opposite sides of the transversal. Okay, so they are on different sides, and they are not adjacent. Okay, so we call this alternate interior. Alternate interior. So we have this like alternate interior angle pair. That's the name of this. All right, we go to the third. Let's have another two lines with a transversal. Okay, and here's the third pair. Okay, one over here and one over here. So you see here non-adjacent angle pair, both exterior, different sides of the transversal. And you call this alternate exterior. angle pair there. Okay, alternate exterior angle pair. All right, the fourth angle pair, this is the fourth. We have two lines and a transversal. Okay, one angle here and another one over there. So two lines with a transversal. These are two interior angles on the same side. Okay, two interior angles on the same side. So if you're going to have the name of this, two interior angles on the same side of the transversal. There, okay? Two interior angles on the same side of the transversal. So that's it for the configurations that we're going to use. So let's start with the first number. All right, the first instruction, find the measure of the indicated angle that makes lines U and V parallel. Okay, you can see the configuration of the angles. One interior, one exterior. The unknown is the exterior angle. Now, this pair is called corresponding angle pair. Okay, and we have a theorem for this. Okay, so we shall type the theorem. Okay, here's the theorem. If two lines have a transversal and a pair of congruent corresponding angles, then the lines are parallel. There, okay? Then the lines are parallel. So if two lines have a transversal and a pair of congruent corresponding angles, then the lines are parallel. So what do we mean by this? What's the meaning of this theorem? All right, it means like this. If two lines have a transversal, okay, and a pair of congruent corresponding, okay, angles, congruent means equal, then the lines are parallel, these two lines here, okay? If this angle and this angle are equal in measure, then the lines are parallel. That's the meaning of this theorem. All right, so let us start solving it. Let me clear my added drawings. Okay, we have here 46, the interior, okay? The other one is also 46, okay? So that the lines U and V are parallel. All right, so our answer should also be 46 degrees. That should be 46 degrees. All right, this is our answer. The computer can verify that over there. It's 46 degrees. All right, so we're correct with the first number. Let's continue with the next. Let me just clear the screen. Number 2. Okay, here's number 2. All right, examine the angle pair. We have one interior, one exterior on the same side of the transversal. So this is clearly corresponding angle pair. Corresponding angle pair. So we will use the same theorem. Okay, the same theorem. You can just read it. If two lines have transversal and a pair of congruent corresponding angles, then the lines are parallel. Our answer there must be 100 degrees also. That should also be 100 degrees. There. Okay, so that the lines U and V are parallel. Okay. All right, and we can verify that. There, it's 100. All right, so we're correct. Let's continue with the third. Let's continue with the third. Okay, here's number 3. Find the value of x that makes lines u and v parallel and solve for the unknown angles. All right. So examine the figure. We still have a corresponding angle pair. Okay, corresponding angle pair, and of course we will still apply the same theorem. Okay, so we will write the theorem on top there, and we're now going to set up the equation. We're supposed to find x here. Okay, we cannot solve it by inspection. All right, and so for the solution, we will set up the equation. They're supposed to be congruent so that lines u and v are parallel. So we have here 2 plus 8x. That should be equal to 50. So solving for the equation, we subtract 2 from both sides. This gives us 8x, which equates to 50 minus 2, that's 48. And we continue by division. 8x by 8 must be equal to 48 by 8. And x is equal to 6. There, okay? All right, and so we found the x. We can solve for the value of the angle. Okay, we can solve for the value of the angle. Solving for the angle. Solving for the angle. We have now 2 plus 8x. 2 plus 8x means 2 plus 8 times the 6. Okay, our value of x, that should be 6. And we have 2 plus 48. And that gives us 50 degrees there. And that's the answer. Okay, let's continue with the fourth. Let me clear the screen. Let's continue with the fourth. All right. Number 4. Find the value of x that makes lines u and v parallel and solve for the unknown angles. The x will have to be found. Also, the measurement of each of this. Okay. All right. So the angle pair that we have, we still have a corresponding angle pair. So the same theorem is applied there. Okay, the same theorem. If two lines have transversal and a pair of congruent corresponding angles, then the lines are parallel. Okay, so we start the solution. We solve for x first, okay? All right, so we have the angles equal. So that means 12x minus 4 must be equal to 10x plus 10. Okay, so we have this equation. Solve for x first. We shall subtract the 10x first. Subtract the 10x, and left side we have 2x minus 4. That's equal to 10. And add 4. Add 4 to both sides. And we have 2x at the left. Right side is 14. So we continue by division. 2x divided by 2 must be equal to 14 divided by 2. X is equal to be 7. All right. Okay, shall we verify first? X equals 7 over here. There. And so we're correct with our x. How about solving for the angles? Let us solve for the angles. Solve for the angles. And we have 12x minus 4. 12x means 12 times the 7. And then we subtract the 4. That looks like 84 minus 4. We have 80 degrees. And that's for the first angle. Okay. Next, we use the 10x plus 10. Use now the 10x plus 10. That should be plus 10, and then 10 times x means 10 times 7 plus 10. And that will be 70 plus 10 means another 80 degrees. There. And we are correct. The two angles are both 80 degrees. They're supposed to be congruent so that lines U and V are parallel. Number 5 now. Let's continue with number 5. Okay, here's number 5. Let's examine the angle pairs. We have one interior, one exterior on the same side of the transversal. We have corresponding angles. So we can still apply the same theorem. There's the theorem. That means the two angles must be equal, okay? Equal in measure. All right, for our solution, 15x must be equal to the 14x plus 5. Solve for x first. We subtract the 14x from both sides. We get 15x minus 14x. That will be x equal to 5, okay? And so our value of x here is 5. And we can verify that. Okay, over here. All right, it's a 5 and our x is correct. Okay, let us solve for the angles. Let us solve for the angles. So solving for the angles, we have the first expression, 15x for the first angle means 15 times the x, 15 times the 5, which gives us 75 degrees. There. We use now the second, that's 14x plus 5. Let us use now the 14x plus 5. And this is 14 times x, 14 times the 5, plus the 5. And so we have 70 plus 5, giving us another 75 degrees. And we have two 75 degrees. They're equal. That means the lines U and V are parallel. The answers are 75 degrees, the required angles. All right, now next will be number 6. Let's continue with the next. Let's continue with the next, number 6. Here's number 6. What type of angle pair? One exterior, one interior on the same side. That means corresponding angle pair again. There. And the same theorem is applied. And for our solution, we have to set the angles equal. So 14x plus 2 must be equal to 100. So we're going to solve for x first. Subtract 2 first from both sides. Subtract 2, and we have 14x equal to 98. Okay, so 14x divided by 14, that's equal to 98 divided by 14. And x is equal to, how much is that? 7. Yes, 7, okay. And that's our x. We can verify that in the other diagram. Computer shows it's a 7, so this is correct. Solve for the angles. The required angles will be, solving for the angles, we have one of the angles is given, it's 100. So we will use the 14x plus 2. 14 times x means 14 times the 7 plus 2. And this means 98 plus 2, which means 100 degrees also. Okay, so this is our solved answer, okay, 100. Okay, and so we continue with number 7. Let's continue with number 7. Okay, here's number 7. Okay, let's examine the angle pair. This is interior. This is another interior. This is not corresponding, okay? Looks like alternate interior angle pair. And so we shall have a new theorem for this, okay? So the theorem will be if two lines have a transversal and a pair of congruent alternate interior angles, then the lines are parallel there. If two lines have a transversal and a pair of congruent alternate interior angles, then the lines are parallel. All right, let's have the copy of that for the other numbers. Okay, all right. And so we have an alternate interior angle pair. By inspection, they're supposed to be congruent so that the lines U and V are parallel. The answer must be 95 also. So the answer must be 95 degrees. There. This is the required angle. And we can verify that. Okay. Over here, the required answer is 95 degrees. All right, let's continue with number 8. It should be 95 degrees so that lines U and V are parallel. Okay, number 8 now. Let's have number 8. Okay, here's number 8. Find the measure of the indicated angle that makes lines U and V parallel. Find the measure of the indicated angle. Let us examine the diagram first. We're looking for this angle, an interior angle, and a given angle is over there, 125 degrees. Okay, and the angle pair looks like an alternate interior angle pair. So we can have the theorem, all right, and this is the theorem. If two lines have a transversal and a pair of congruent alternate interior angles, then the lines are parallel. A little explanation there. If two lines have a transversal, okay, and a pair of alternate interior angles, okay, if those two angles are congruent, meaning equal, then these two lines are parallel, okay? That's the meaning of the theorem. All right, so let's proceed to our solution. Okay, you can identify the angle there. Okay, that should also be 125 degrees because of the required condition. Okay, if the two angles are equal, then lines U and V are parallel. So the answer is 125 degrees. There. 125 degrees is the answer. And we can verify that there. Over here, at the lower portion of the diagram, the computer displays the answer. It's 125 degrees also. Our answer is correct. Number 9 now. Let's continue with number 9. Okay, here's our number 9. Okay, find the value of x that makes lines U and V parallel and the measure of the unknown angles. Okay, one of the angles is already given. It's 80 degrees. Okay, what should be the value of x so that the other angle is also 80 degrees? All right, so we have here what kind of pair? We have an alternate interior angle pair. So we can still apply the theorem, okay? If two lines have a transversal and a pair of congruent alternate interior angles, then the lines are parallel. So we set our working equation. 8 plus 12x must be equal to 80. So solving for x now, subtract the 8. Subtract the 8. Left side becomes 12x. Right side is 80 minus 8. That is 72. So next step is divide. 12x divided by 12 equals 72. Divide by 12. And our answer must be 6. All right, so this is our x. All right, we can verify that. Okay, it's 6. That means this is correct. How about verifying the angle 8 plus 12x? Will that be equal to 80? Let's solve for the other angle. Okay, using 8 plus 12x means 8 plus 12 times the 6. And we get like 8 plus 12 times 6, 72. 8 plus 72 is 80. 80 degrees. There. And correct, okay? The other angle is 80 also. All right. Number 10. Let's continue with number 10. All right. Here's number 10. All right. What kind of angle pair? One interior, opposite side. Okay. That means alternate interior. We apply the same theorem. This is our second theorem. If two lines have a transversal and a pair of congruent alternate interior angles, then the lines are parallel. So for our solution, we're supposed to solve for x first. We'll be using 32x minus 3. That should be equal to 125. Solving for x starts by adding 3. Add 3. Left side becomes 32x. Right side is 128. All right, next step is divide. We have 32x divide by 32. That'll be equal to 128 divide by 32. X is 4, okay? All right, and so that's our answer. X is, computer's verification, X is 4. There, okay, so this is correct. All right, find the values of the angles. All right, one of the angles is 125. Let's see if 32x minus 3 is also 125. By using the x, let's do a little verification. Solving for the other angle, we shall use 32x minus 3. That's 32x means 32 times the 4 minus 3 afterwards. So 32 times 4 is 128, and then we subtract the 3, which gives us 125 degrees. Okay, correct. Okay, the other angle is also and supposed to be 125 also. Continue with number 11 now. We will clear the screen. Let's have number 11. Okay, number 11. Here's number 11. Okay, here's number 11. Find the value of x that makes lines u and v parallel and the measure of the unknown angles. All right, the angle pair is another alternate interior. Okay, so we can still apply our second theorem there. Okay, if two lines have transversal and pair of congruent alternate interior angles, then the lines are parallel. So the two angles must be equal. So in our solution, we equate the angles. 36x minus 3 must be equal to 105. Okay, and we solve for x. So we add 3 first and add 3. So 36x must be equal to 108. Next step is divide. 36x divided by 36. That is equal to 108. And we divide by 36. All right, so x will be equal to about 3. Because 36 times 3, that's 108. All right, so 108 divided by 36, that should be 3. All right, so this is our answer. Computer verification. Yes, it's 3. There, this must be correct. All right, let's evaluate the other angle if it's equal to 105. Okay, so solving for the other angle, we have now 36x minus 3. That'll be 36 times x, which is now 3, and then deduct the 3. So that's 108 minus 3. That should be 105. That should be 105 degrees. There. Okay, so that's it. It's correct. Should be equal to the given 105. All right, so we continue with number 12. Let's clear the screen for number 11. Continue with number 12. All right, let's continue with number 12. Okay, number 12 is here. All right, let's read the instruction. Find the value of x that makes lines U and V parallel, and the measure of the unknown angles. All right, the angle pair looks like another alternate interior, as you can see from the figure, alternate interior, okay? All right, so we can apply the same theorem, all right, there. And we shall set up our solution using the equation. X plus 55 must be equal to the 50. We solve for x now by subtracting the 55 from both sides. We get x equal to, our subtrahend is larger, so it must be a negative 5. Okay, that goes to our answer. You can verify the answer over here. It's a negative 5. And so we can compute the other angle, okay? The x plus 55. Solve for the other angle. And we have x plus 55, that's negative 5 plus 55. We have 50 degrees. And that's it, it's correct. Next, number 13. Let's continue with the number 13. All right, what do we have there? All right, we have another type of angle pair. Okay, you can see this is an exterior unknown angle and exterior over there. So that means we have an alternate exterior angle pair. And we shall have a new theorem for this. Okay, we shall use a new theorem. And this theorem is if two lines have a transversal, okay, and a pair of congruent alternate exterior angles, then the lines are parallel. There. This is our third, okay? Our third theorem. Okay, let's copy it for pasting the next lines, all right? Okay, so if two lines have a transversal, explanation, if two lines have a transversal, okay, and a pair of congruent alternate exterior, congruent meaning equal, okay, then the lines are parallel. These two lines, okay, that's the meaning. All right. Okay, so find the measure of the indicated angle, the one with the question mark. All right, by inspection, that should be 131 degrees. Okay, that is also 131 degrees. There, that should be the answer. So that these two lines are parallel, okay? All right, let us see the answer. There, okay? That's 131. So our answer is correct by inspection. All right, let's continue with number 14. Let's continue with number 14. Let me clear the screen. Okay, here is number 14. Find the measure of the indicated angle that makes lines U and V parallel. All right, the angle pair is alternate exterior. We're looking for that angle with a question mark. And that should be 93. That should be 93 there. Okay. All right. So the value of the angle will be 93 degrees. 93 degrees. There. Okay. We can verify that. All right. You can see the portion below the diagram. That's the right answer. Number 15. Let's continue with number 15. Let's clear the screen. Next, number 15. All right, here's number 15. Find the value of x that makes lines U and V parallel. Also find the angle. All right. Okay, the angle pair that we have is another alternate exterior. So we apply the same theorem. This theorem, okay? Alternate exterior. Okay, alternate exterior angles. All right, if two lines have a transversal and a pair of congruent, meaning equal, they should be equal so that these two are parallel, okay? All right, so we can set up our equation. We have x plus 1, 3, 1. That should be equal to 1, 2, 3. And so we solve for x here. Very simple equation. This is minus 1, 3, 1 from both sides. And we have x equal to, how much is that? Negative 8. That should be our x. Okay, and we can verify the answer. It's a negative 8 there. All right, so that's it. We can solve for the other angle. We will use x plus 1, 3, 1. X is negative 8 plus 1, 3, 1. That's 1, 2, 3 degrees. There, okay? 1, 2, 3. All right. That's equal to the given 123 degrees. And our x is negative 8 as verified over there. All right. Continue with number 16. Let's clear the screen. Let's have number 16. Okay, here's number 16. From the diagram, it shows alternate exterior. One exterior over here, one exterior over there. All right, we can use the same theorem. All right. There. If two lines have a transversal and a pair of congruent alternate exterior angles, then the lines are parallel. So let us set up our solution. And the angles are supposed to be equal. So we will have 6x plus 11 must be equal to 2 plus 7x. Okay, and we start by subtracting the 6x, the lower value. Okay, the lower value. So minus 6x minus 6x. And so left side is 11. That equates to 2 plus 7x minus 6x. That will just be x. Subtract now 2 from both sides. Okay, that will be minus 2. And we have 9 equals x. Now, we don't write it that way. We will have the x first. X equals 9 there. And so this is our x value. Verify there. And so this is correct. We can now solve for the values of the angles, okay? Because those are algebraic expressions, we shall solve for the angles. Solve for the angles. Okay, the first one is 6x plus 11. 6 times x means 6 times 9 plus 11. And so we have 6 times 9 is 54. Add 11. That will be 65. 65 degrees. Okay, that will be one of the angles. Let's use now the other one. The other expression is 2 plus 7x. 2 plus 7x. 2 plus 7 times the x, which is 7 times the 9, which gives us 2 plus 63. And we have like 63 plus 2, which is 65 degrees. There. And so they are supposed to be equal, okay? All right. Those are the actual values so that the lines are parallel, okay? These two, okay? The angle pair must be equal. Number 17 now. Let's continue with number 17. Okay, number 17. Here's number 17. And the diagram is over there. We're asked to find the value of x that makes lines u and v parallel and the measure of the unknown angles. Okay, the angle pair is another alternate exterior angles, okay? This angle and this angle makes alternate exterior angle pair. So we can apply the third theorem over here. If two lines have transversal and a pair of congruent exterior, all right, alternate exterior, then the lines are parallel. All right, let us set up our solution. The angles must be equal. So 28x plus 1 must be equal to 27x plus 4. And so for x first, we subtract the 27x first from both sides of the equation. All right. We're going to get 28x minus 27x is just 1x, or simply x, plus the 1. And that equates to 4. Okay, afterwards, we subtract the 1 from both sides, and we get a 3. X is equal to 3. That's our x value. Our x value is 3. And so we can verify that. All right. At the lower part of the diagram, you can see the confirmation there. Our x is 3. All right. Solve now for the angles. Solve for the angles. We can use now the 28x plus 1. 28x means 28 times the 3, okay? And we have to add 1. All right, how much is that? 24 and a carry 2, that's 84, okay? 84 plus 1 means 85 degrees. All right, that will be our first value. We're now ready to use the other one, okay, over here. That will be now 27x plus 4. 27x plus 4 means 27 times the 3 plus 4. And this gives us 21 and 2, 81 plus 4. 81 plus 4 means another 85 degrees. All right, so we have the answers congruent, 85 and 85. All right, they are supposed to be expected equal so that the lines here are parallel, okay? Those are the answers, the x and the angles. Number 18 now. Let's continue with 18. Number 18. Here's number 18. All right. Oh, this one looks simpler okay? But the same configuration, alternate exterior, and we have a simpler equation here. But the same theorem is applied. So for our solution, we now have 21x must be equal to 105. 105. And so we proceed by division. 21x, we divide by 21, and we have 105. 105, we divide by 21. There. And x must be equal to, how much is that? 5, okay? Yes, that should be 5. And so our x is 5, all right? How about the computer? It's a 5, okay? Right there. So this is correct. All right. So we can now continue with the angles. Let us solve for the angle. One of the angles is given 105. So we will just solve for the other angle. And so we have 21x. This means 21 times the x. That's 5. 21 times 5 is 105. So our angle is 105 degrees. Okay, so that's correct. They are both 105 degrees. Continue now with number 19. Let's continue with the number 19. All right, number 19. All right, here is number 19. The configuration is different. This is the fourth configuration. We have two angles on one side of the transversal. The unknown angle is there. The given angle is there. And these are two interior angles on the same side of the transversal. So we have a different theorem here. Okay, let's have the fourth theorem. And this is if two lines have interior angles. Okay, two lines have interior angles on the same side of the transversal. On the same side of the transversal that are supplementary. Okay, then the lines are parallel. Okay, then the lines are parallel. There. Okay, let us have it copied there. All right, so we can just post it in the next problem. All right, because these are in groups. Okay, so the remaining problems will be all interior angles on the same side. Okay, so here's the theorem. If two lines have interior angles on the same side of the transversal that are supplementary, supplementary means the sum is 180, okay? Then the lines are parallel. So let's have a little explanation there. If two lines have interior angles on the same side of the transversal, okay, that means interior, one here and one here. They are both on the same side, okay? Okay. The two lines have interior angles on the same side of the transversal that are supplementary, meaning this plus this equates to 180 degrees, okay? Then the lines are parallel, these two, okay? So these two lines can only be parallel if the sum of those two equates to 180 degrees, okay? That means when you add those two, interior on one side of the transversal, it must be 180 so that the lines are parallel, okay? So that these two lines are parallel. All right, so let's solve. Let us solve, okay? And Okay, let me just write the theorem. All right, there. Okay, if two lines have interior angles on the same side of the transversal that are supplementary, then the lines are parallel. All right, so our working equation here must be solution. We let x, the unknown angle in the question mark, okay? Let x be the unknown angle. There. Okay, so we have x plus the 54. That should be equal to 180. All right, let us solve. So we start by subtracting the 54 from both sides. Subtract the 54. And so x, this must be equal to, how much is that? 10 minus 4, 6. That becomes 126, okay? 126 degrees. We're talking about angle measure here for x. So the answer is 126 degrees. Okay, that's the answer. So that these two lines are parallel, okay, parallel. All right, let us verify. Okay, so we have there 126, 126. Let's now proceed to number 20. Let's have number 20. Okay, here is number 20. Okay, the diagram shows us another pair of two interior angles on the same side. Okay, one over here and one over here, the unknown. And so we apply the same theorem there. So that our working equation should be, all right, our working equation should be, all right, let x be the known angle. Okay, and we have the question mark must be represented by x. So x plus 118 must be equal to 180. They're supposed to be supplements to each other. So when we add these two angles, it must be equal to 180. Solve for x now. So we deduct 118. We deduct 118. And x is equal to 180. That becomes 62. Okay, 62 degrees. That should be it. That's our angle. There. It is 62 as verified. All right, there. Okay. So remember, they are not equal. Okay. You might answer 118. That will only be for alternate interior, alternate exterior there. Okay. Or corresponding. All right. But these are two angles on the same side, and they're both interior. Okay. All right. So you really have to understand the configurations or each type of angle pair. Okay. So that the lines are parallel. All right. So let's continue with the 21. Let's have the 21. Let me clear the screen. Okay, number 21 is here. All right, the same configuration, two interior angles on the same side of the transversal. Okay, so you can see one angle there and another over there. And so we can still apply the same theorem. Okay, if two lines have interior angles on the same side of the transversal that are supplementary, then the lines are parallel. All right, how about our working equation? Let us start with our solution. Okay, we have the first angle x plus 67, x plus 67, and this is added to x plus 127. There. When these two angles are added, the sum should be 180 degrees, okay? So we solve for x first. Removing the parentheses, we have x plus 67 plus x plus 127. This must be equal to 180. All right, x plus x is 2x. 67 plus 127. How much is that? So that will be 14. Carry 1. That should be 9 and 1. Okay, 9 and 1. So we have a 194. All right, that equates to 180. All right. Next step is subtract. Okay, so we're going to subtract. All right, subtract which one? The 194. Okay, so we're going to subtract the 194 from both sides. And the left side becomes just 2x. The right side will be 180 minus 194. 194 is larger. That's the subtrahend. Our answer there will be a minus, okay, or a negative, and that must be 14, okay, a negative 14 there. All right, and so we continue by division. We will now have divide 2x by 2, and that will be equal to negative 14 divide also by 2. We find our x negative 7, okay, and this our x there. Okay, let's verify. It's a negative 7 there, so this is correct. All right, how about the values of the angles? All right, let us solve for the angles. Solve for the angles. All right, we have x plus 67. X plus 67. We will have now negative 7 plus 67, and that looks like 60. All right. Next, we use the other expression. The other expression is x plus 127, x plus 127. We have our x negative 7 plus 127. It's 120. This is also degrees. So a little check will be 60 plus 120, that's 180, okay? So these are the right answers, okay? Because you can check that. You can also check that. That's 60 plus 120, okay? That should be equal to 180, of course, okay? There, 180 degrees. All right, and so our checking is correct. 60 plus 120, that's 180 degrees. So the answers are correct, the angles, right? And the x, of course. Let's continue with the 22. Let's clear the screen. All right, let's continue with 22. Here's number 22. Find the value of x that makes lines U and V parallel and the measure of the unknown angles. All right, the same theorem is applied. Okay, the same theorem. If two lines have interior angles on the same side of the transversal that are supplementary, meaning the sum is 180, then the lines are parallel. Okay, so we have to set up our equation. We have the solution. Okay, let us set up our solution. Solution. We have the two angles 12x minus 4. That's the first angle. We're going to add the other 14x plus 2. This must be equal to 180, like that. Okay, let us now remove the parentheses. So our equation becomes 12x minus 4 plus 14x plus 2. That should be equal to 180. All right, combining like terms, we have 26x for the x terms, and negative 4 and positive 2 results to negative 2 there. And this equates to 180. All right, add 2 to both sides now, add 2, and then add 2. So the left side is 26x, the right side is 182 there. All right, is it divisible by 26? 26x divided by 26 is 182 divided by 26. So x will be, all right, how much is that? 182 divided by 26, how much? 182, and by 7, 42 and 4, 14, 16, 18. 7, okay? All right, 26 times 7 is 182, so it's a 7. Yes, it's a carry 4, and then 14 plus 4, that's 18. All right, it's a 7. X is equal to 7, and we can verify that. X is equal to 7, okay, there. All right, and so this is the right X. We shall solve for the values of the angles, okay? Solve for the values of the angles. All right, over here at the right side, solve for the angles. We shall start with 12x minus 4. 12x means 12 times dx. 12 times the 7, and then we subtract the 4. 12 times 7 is 84. All right, 84, then we deduct the 4. We have something like 80 degrees. Okay, all right. How about the other one? All right, we shall try to use the other expression over here. That's now 14x plus 2. 14x plus 2. Okay, we have 14 times the x. That means 14 times the 7, and then add 2. That's 28. That's 28 and 2, 98. Okay, so we have 98 plus 2, which gives us 100. Okay, that gives us 100 degrees. All right, and so we have the two angles, 80 and 100. 80 plus 100, that's 180. Okay, a little check there. That means the angles are correct. Okay, they are supplementary. All right, and our x is also correct at 7. Continue now with 23. Let's continue with 23. All right, let's have the next. All right, here's the next. All right, we have here what type of angle pair? What type of angle pair? One over here, that's interior. This is also another interior. And they are both on one side, okay, of the transversal. They are both interior on the same side. We apply the same theorem. There, okay? Two lines have interior angles on the same side of the transversal. Okay, these are interior, okay, on the same side of the transversal. And if they are supplementary, then the lines are parallel. Okay, so we will be having our working equation. All right. Solution will be first angle. Okay, our first angle is a number. All right, 66. And then added to another angle, negative 6 plus 10x. That's the expression for that angle. Negative 6 plus 10x. Added together equates to 180. There. All right. So remove the parentheses. 66 plus a negative 6 becomes a minus 6. And then the plus 10x remains plus 10x. And this equates to 180. All right. 66 minus 6, that's 60. We still have the plus 10x, that's equal to 180. All right, so we continue by subtracting the 60. Subtract 60. And then subtract the 60. All right. Left side is just 10x. The right side is 180 minus 60. That's 120. Okay. 0 minus 0, 8 minus 6. Bring down 1, so 120. Division now. So we'll have 10x divided by 10 is equal to 120 divided by, okay, that is divided by 10. All right, x is clearly 12, okay? All right, that should be equal to 12. And that's it. All right, that's our x. How about the computer's confirmation? Look at the lower part of the diagram. There, it is 12 there. All right, so that means our answer is correct. All right, we compute now for the other angle. One of the angles is 66. Let's compute for the other angle. Solve for the other angle. All right. Okay, we have the other angle is expressed -6 plus 10x. You can also write that 10x minus 6. Okay, same thing. All right. So 10x means 10 times our x, 10 times 12 minus the 6. And we have like 120 minus the 6. All right, how much is that? 114 degrees there. That's our answer. Okay, there. That's 114. Now a little check. 114 plus 66. How much will that be? A little check over here. All right. Check. We have 114, and then we add 66. 10, carry 1, 8, bring down 1. That's 180. All right. And so the values of the angles are correct. Okay. This must be the right value, 114. Last number. Let's have our last number, number 24. Okay, here is number 24. The same configuration. Okay, this angle and this angle are two interior on the same side. All right, so we apply the same theorem. Okay, this is the same theorem. If two lines have interior angles on the same side of the transversal that are supplementary, then the lines are parallel. Okay, all right. Okay, so let's have our solution. Okay, one of the angles is 14x plus 9. Okay, and we're going to add the other one, which is 6x minus 9. So the total of these two angle expressions is equal to 180. They are supposed to be supplementary. Find x that makes lines U and V parallel and the measure of the unknown angles. That's the instruction. All right, so we solve the equation by removing the parentheses first. That will become 14x plus 9 plus 6x minus 9, and that equates to 180. All right, 14x and 6x makes 20x. The 9 cancels out, okay? One positive, one negative, so it cancels out. And so 20x must be equal to 180. All right, division now. 20x by 20 is equal to 180 by, all right, divided by 20. All right, what do we have? X is equal to 9. All right, that should be it. That's our X. All right, let us check and verify. X is 9. Yes, there. So that's correct. All right, determine now the values of the angles, numerical values, not algebraic expressions. Let us find the angles. All right, let us find it on the right side. Solve for the angles. All right, we have 14x plus 9. 14x plus 9. Okay, we have 14x means 14 times the 9 plus 9. There, what do we have? That's 36, carry 3. That's 126. All right, plus 9. That makes 135. 135 degrees. Okay. Yes, 135 degrees. How about the other one? The other one is 6x minus 9. Let's do it at the extreme right side. We have there 6x minus 9. 6x means 6 times our x. Our x is 9. Minus 9 there. All right, 6 times 9 is 54 minus 9. That looks like 45, okay? 45 degrees. 45 degrees. There. Okay, a little check. 135 plus 45. Okay, you can check that. Check. We have 135 plus 45. Okay. That results to 10 carry 180. Yes, 180 degrees. There. Okay. So that means our angular measurements here in degrees are the right answers. Okay. There. All right. That's it for our proving lines parallel. I hope you were able to learn from the examples, and we will be discussing more later. So see you later. This will be all for now. See you later.